All right, here we go. All right, so the first thing we want to do today is work on that problem set that we have. Number 2, that is. So let me open it up for you to remind you what it looks like. So basically, it's, as you can see, it's all about comparative advantage. And there's quite a few questions here, but by the time you're done with it, you will be the world's ultimate expert in comparative advantage, that's for sure. All right, so first let me save this for a second. Okay, now, what do we have here? So we've got a table showing us the quantity of labor used to produce coffee and tea. Okay. So what we want to know, so let's see. What they're telling us here is that in the US, we can make a pound of tea with an hour of labor. In Brazil, it takes 6 hours. Whereas at the same time, though, a pound of coffee requires 3 hours labor in the United States, and it takes only 1 hour in Brazil. All right, so we're going to answer a bunch of questions about comparative advantage and opportunity cost. So why don't we begin here with the opportunity cost that the US incurs in order to produce a pound of tea. Now remember that with opportunity cost, what you're actually calculating is the sacrifice of the other good. In other words, here it's sacrificed coffee over the gained tea. Now, how do we know? Well, let's think about this. In order for the US to make a pound of tea, it has to give up 1 hour of labor. And that means that's 1 hour of labor that could have been used to produce a pound of coffee. So therefore, since it takes 3 hours to make a pound of coffee, that 1 hour of labor that is being used to make tea could have been used to make 1/3 of a pound of coffee. All right, so we're giving up 1/3 of a pound of coffee divided by 1 pound of tea. So hold on one second. Let's move it down here. 1/3 pound sacrificed coffee divided by 1 pound gained tea equals 1/3. Okay. Or you can think of it as 1 pound of coffee is being given up for every pound of tea that we make. So again, because it takes an hour to make a pound of tea, if we do make that pound of tea, we use up an hour of labor that could have alternatively been used to make 1/3 of a pound of coffee. Why? Because each coffee takes 3 hours, so therefore 1 hour could only enable us to produce 1/3 of a pound of coffee. Okay, so actually this is measured as pounds of coffee. So ultimately, the opportunity cost of the tea is 1/3 of a pound of coffee. On the other hand, when we look at this backwards, if we think in terms of what is the opportunity cost of producing coffee, well, that opportunity cost would be the sacrificed tea divided by the gained coffee. All right, so actually, by the way, hold on one second. I'm going to split the screen so we can always see the chart. All right, so in order to make coffee, we have to use 3 hours of labor. And by doing so, we're giving up the opportunity to produce 3 pounds of tea, right? So the 3 hours that we are using to make coffee could have been used to make 3 pounds of tea because each pound of tea only takes an hour. So in this case, we're looking at 3 pounds of sacrificed tea divided by 1 pound of gained coffee equals 3 pounds of tea. All right, now also I'd like to remind everybody, just as a helpful hint here, that in a case like this, the opportunity costs of tea and coffee are inverses of each other. So if this one is 1/3 of a pound of coffee, this one must be 3 pounds of tea. All right, so that's kind of a helpful hint. It helps you double check your results when you think about it that way. All right, now for Brazil to make tea, the opportunity cost is calculated in exactly the same way. How much coffee did we give up to make 1 pound of tea? All right, well, in this case, if they make tea, it takes up 6 hours that could have been used to make 6 pounds of coffee. So here we have 6 pounds of coffee being given up to make 1 pound of tea. So therefore, the final answer here is 6 pounds of coffee. Then we would do the opposite. We want to know what Brazil's opportunity cost is to produce a pound of coffee. And so once again, the calculations are exactly the same as they are in the United States. So this formula will be used, the opportunity cost of coffee equals the sacrificed tea over the gained coffee. So if they make coffee, they only need 1 hour of labor, whereas that would only help us produce 1/6 of a pound of tea because each pound takes 6 hours. So what we're looking at here is 1/6 pound of tea sacrificed in order to gain 1 pound of coffee gained. So the bottom line is it's 1/6 of a pound of tea. Okay, so those numbers are calculated. So if you want to, not that it's absolutely necessary, you could make up a little chart here, which I think might be very helpful to organize our results. Let me put that right here. And so we can just say, what is the opportunity cost in each country of making that product? Instead of the hours of labor, we'll switch this over to the opportunity cost. And that way it'll make it easier to find the correct solutions to what we're about to do. So for the US, the opportunity cost of the tea is 1/3 pound of coffee. And therefore the opportunity cost of the coffee is 3 pounds of tea. In Brazil, the opportunity cost of the tea is 6 pounds of coffee. And here we have 1/6. Okay, we don't really need the units here, but I mean, we can put them in if you want to. This would be pounds of coffee. This would be pounds of tea. This would be pounds of coffee. And this would be pounds of tea. Okay. So now we don't need this chart anymore. We need this chart to help us figure out what's going on with these other questions. So for example, which country has the absolute advantage in the production of tea? All right, well, I guess I was mistaken. We do need this chart. The absolute advantage comes from the idea that it takes Brazil 6 hours of labor versus only 1 hour in the US. So therefore, we say that the US has the absolute advantage in the production of tea. Okay, so we'll say that the US has an absolute advantage in the production of tea because it can produce tea, 1 pound of tea with 1 hour of labor compared with 6 hours in Brazil. Okay, so we know that the US has the absolute advantage there. What about the coffee? Well, in that case, the advantage swings back to Brazil. Brazil has an absolute advantage in the production of coffee because it can produce 1 pound of coffee with only 1 hour of labor compared with 3 hours in the United States. So that's what we're looking for. We're trying to figure out who can produce the good with the fewest hours of labor, or in general, with the fewest resources. Okay, so once again, let's look at this chart. You can see that the US can make tea very quickly compared to Brazil, but Brazil can make coffee much more quickly than in the United States. Okay, so those are the two absolute advantages. The comparative advantages come down to the opportunity costs. So you can see here for tea, the US has a lower opportunity cost. So therefore, the US has the comparative advantage in the production of tea because it has the lower opportunity cost. Or I guess what I should say is it has a lower opportunity cost than Brazil. And if you want to be very specific, you can say 1/3 of a pound versus 6 pounds. Just to make it clear that clearly the US has much lower opportunity costs in the production of tea. But on the other hand, if you look at this chart, you'll see that clearly Brazil has the lower opportunity costs in the production of coffee, only 1/6 of a pound compared with 3 pounds of tea. Okay, so Brazil has the comparative advantage in the production of coffee because it has a lower opportunity cost than the US. And again, if you want to compare them side by side, it's 1/6 versus 3 pounds. And so that's the reason. Okay, now, based on the data in the previous problem, the US has 1,800 hours of labor to it, and Brazil has 1,500 hours of labor. All right, so we'll need this chart again. So I'll just copy it down here. All right, just so we don't have to flip back and forth 8,000 times. All right, there's the chart. So let's remember the US has 1,800 hours. And Brazil has available to it 1,500 hours. Okay. All right. Well, so these next set of questions is going to be pretty straightforward because, as you can see, if the U.S. specializes in the production of tea, it can make 1,800 pounds of tea. How do you know that? Because we have 1,800 hours of labor divided by 1 hour per pound. Okay, so you could write this as 1,800 hours of labor divided by 1 pound of tea per hour. Okay. Now for coffee, we're going to only be able to make 600 pounds of coffee. All right, and why is that? It's 600 pounds of coffee because that's 1,800 hours of labor divided by 3 Oh, you know what? Let me just write this slightly differently. 1 hour of labor per pound of tea. I think that would be more realistic. I mean, more consistent. So here, I want you to see that it takes 3 hours of labor per pound of coffee. So therefore, the ratio that I need in the first case is 1,800 over 1 for 1 hour. And here I need 1,800 divided by 3. So even if I specialize completely in coffee, or the US at least, can only make 600 pounds. Now we'll do the same thing for Brazil. So Brazil, if they only make tea, they can make 250 pounds of tea because they only have 1,500 hours of labor. And we have to divide that by 6 hours of labor per pound of tea. So they can't make a whole lot of tea in Brazil, but they can make a lot of coffee. So for the coffee, they can make 500 pounds because they have 1,500 hours of labor, and it takes 3 hours of labor per pound of coffee. All right, so those are our final results. So that was pretty straightforward. I mean, really, all they're asking you to do is figure out, if you were to specialize in a good, how much could you potentially produce? Okay, so we're going to assume now in part 3 that without trade, here's how much is being consumed and produced in the two countries. So let me make another chart here. So the key detail here is that without trade, you can only produce, or you can only consume what you produce. So in other words, if you want 500 pounds of coffee, you have to make 500 pounds of coffee. So the US has 500 pounds of coffee. So, all right, let me change this very slightly. So we've got the US down for 500 pounds. Let's see. These are all pounds, just to keep it simple. It gets very confusing when we have different units. So US can consume and produce 500 pounds of coffee and 300 pounds of tea. While at the same time, though, in Brazil, they're producing and consuming 200 pounds of tea. And how much coffee? 300. Okay, now we're being asked to draw some graphs here. Now, what's interesting about this case, unlike some of the other ones we've seen, these opportunity costs are fixed. They never change. In other words, we can always produce 1 more pound of tea by giving up 1 more third of a pound of coffee in the United States. And the same thing is happening in Brazil. So that means that the production possibilities frontiers will be straight lines. That's something that you could, well, it isn't, it may be immediately obvious, but because of the fact that there's nothing else indicated here, we can assume that the production possibilities curves are flat because the opportunity costs are constants. All right, so what would these look like? Now, it does tell us in the instructions to make sure that we put coffee on the vertical axis. All right, that way we've all got the same graph. So we have, for the United States, coffee and tea. Now, we know from earlier, and for that we'll need this chart, the US is capable of making, here, no, wait a minute. Oh, It looks like, oh, I see what happened. I didn't actually make a chart for that, did I? Well, maybe that should change. Hold on one second. I think that's a great idea. Let's put a chart together for how much can they produce before a trade. Okay, so in other words, before any trade takes place, the U.S. can make 1,800 pounds of tea, and it can make 600 pounds of coffee. In Brazil, we've already seen that they can make 250 pounds of tea, and they can also make 500 pounds of coffee. Okay, I like the idea of having that all together in one nice, convenient location, especially because we're going to need this information now when we draw this curve. All right, so first let me split up the screen so we can see the chart that we need, which is not this one, but this one. This is going to show me where my intercepts are. Okay, so on the vertical axis with the coffee, the US can start at 600. If they choose to make only coffee, they'll be here. Now, if they only make tea, they'll be way down here somewhere at 1,800. So that is our production possibilities frontier. I'm going to label this US before trade. Now, even though it doesn't ask us to do this, we can also identify the point where we are currently consuming and producing. So based on all these possibilities, the US chooses to make 500 pounds of coffee and 300 pounds of tea. So this is where we're currently located on this production possibilities frontier. All right, now what about Brazil? Let's do the same thing for Brazil. Okay, so what's going on over there? They've got the capability of making let's see, what can they produce? So remember, coffee goes here, tea goes here. Brazil, before trade. They can make 300 coffees. Oh, no, I'm looking at the wrong chart again. Brazil, without trade, can make 500 pounds of coffee, and they can make 250 pounds of tea. Okay, so let's draw that. And then we also were told that they choose to make, oh, wait a minute. Oh, I just realized there's a problem here. Yeah, this chart can't be correct. I just realized there's a mistake here. We can't have in Brazil both 200 teas and 300 coffees. So we'll have to make a change here. Sorry about that. Let's say that Brazil decides to go with, how about 200 of each. That should be fine. All right, so I'll have to, let's see, is that possible? Let me just double check something real fast. No, let's make for Brazil. They have 1,500 hours. And they're capable of producing this much of each. So how would they like to split that up? Let's see, hold on one second. About 200 and 300. So they could actually make 200 pounds of tea and 300 pounds of coffee. Okay, let's try that one. Oh, no, that is what it said. Oh, you know what happened? I drew the picture wrong. No wonder. I knew something was wrong. No. You know what was wrong? Everything is fine except for this picture. That's how it got screwed up. For a second, I thought I'd done something terribly wrong. No, these numbers are perfectly fine. What was wrong was my picture. I started at 300 when I should have started at 500. That was the problem. All right, so let me fix this diagram. The numbers you have in there are fine. The diagram was off. All right, so let me fix that right now. So yes, they are perfectly capable of, since they can produce 250 pounds of tea and 500 pounds of coffee, they are perfectly capable of making 200 pounds of tea and 300 pounds of coffee. So that's what we're going to assume. All right, let's do this again. This is Brazil. This is Brazil before trade. So their capabilities are 500 and 250. All right. That's where the problem was. Now we're all set. Yeah, this isn't drawn that well. Let me try that again. It should look more like this. It should be very steep. Okay, now we're getting somewhere. And then they decide to produce 200 teas and 300 coffees. All right, now we're getting somewhere. And that's where Brazil is currently producing in the absence of trade. Okay, so in other words, that point represents production and consumption. Without trade, those have to be equal to each other. We can't import or export without trade. So this point represents production and consumption. Okay, domestically without trade. And now what we're going to do is try to figure out what happens when they do decide to trade with each other. And of course, that means that the US, being so good at making tea, is going to make tea, and Brazil is going to make coffee. All right, so in the next part, oh, wait a minute now. I think we do have to change this one though. Let's make this 300 and 300. Okay, these are probably not correct. What we have to do is determine what happens if they trade with each other. So what we need, let's bring together our charts showing what we were producing before and what we should be producing after. Okay, so we'll have one big chart. So let's have another set of columns in here. All right, now let's say that we do decide to make this trade. This is where they're producing now, but we also need the table that represents specialization. So I'm going to copy that one as well because we'll need them all. We might as well bring them all down here all in one shot. This is what we can do without trade. But this chart up here represents where they choose to consume and produce. So what we're going to basically need is a series of tables. So let's just say that we assume that both countries agree to just specialize in one product. So this is with specialization. And that means the US just makes 1,800 teas and Brazil makes 500 coffees. Now, then we agree to trade 300 teas for 300 coffees. So that comes next. Okay, so with specialization and trade, we're going to subtract 300 from here. The US makes 1,800 teas, and then they trade 300 of them to get 300 coffees, whereas Brazil trades away 500 of those coffees to get to 300 teas. Okay, so in other words, so we've got pre-trade production and consumption. Actually, I'll tell you what, let me change this. This is the thing that's really killing it. Let me change this to 200. It'll just be a little bit easier. So that means down here, we have 1,600, 200, 200, and 300. Nah, see, that's not going to work either. Let's make it 150. This is, you can see how complex this is to plan it properly. Let's make it 150 because I want to make sure that they both end up with more goods than when they started out with. So this would be, yeah. Oh, man, you know what? right. Sorry about this. I have to keep changing it because it doesn't make sense the way it's set up now. Let's try this. The U.S. trades 200 teas to Brazil for 600 coffees. Let's see if that works. So then Brazil sells. No, that's no good because Brazil doesn't make that much coffee. All right, you know what? I'll tell you what. I don't know what happened here. This last one is not set up properly, so we can't. I'll tell you what I'll do. I'll take this back and I'll fix it, and then we'll pick it up again. Everything's okay up to this point, but the ratio of this exchange is just not working out properly. So I'll just take it back and fix it, and then we'll do it again next time. I don't want to waste all day with this. I have to find a ratio at which they both make money or benefit, and it's just not working out for some reason. So rather than waste your time any further, I will just take this back and fix it. It's only this last question. The rest of these are fine, but I have to make some adjustments to the trade between the two countries. So because right now, the way it's set up, it's not working out correctly. Not really, because what's happening is that Brazil is not benefiting at all, and the U.S. is getting all the gains. And I'm trying to make an example where both sides benefit equally, and it's just not happening for some reason. So, all right, so let's put this aside, and we'll pick it up again next week. What I really wanted to do then is let's just set it aside. I'll fix it, and then we'll do it again. But then instead, in the meantime, what we need to do is get some practice with some of the concepts that we looked at earlier, which is to say arbitrage. Okay, where were we with arbitrage? This is chapter 11, number 3. And so we took a lot of time looking at 2 different examples of arbitrage, of which one was triangular arbitrage and the other one was covered interest arbitrage. So what I thought we could do here is maybe get some more practice setting these up and working them out. So I put on Moodle another problem set that we can work on today. Let me go find it here. And it would be right about here. Okay, I'm not logged in. Right at the very bottom here, I put in what I'm calling my additional practice problems. And what this is going to be is an opportunity to get some more practice doing both of these 2 types of arbitrage, triangular and covered interest arbitrage. So why don't we take a look at this first one? So we've got 3 different exchange rates, as we always do in these cases. And we notice that it costs $2 to buy a pound. It costs 110 yen to buy $1. And we have a cross exchange rate here of 240 yen per pound. Now, we're assuming that a U.S. trader is watching these very carefully. He has $1 million to spend. Let's say this is his bank's money, and he wants to earn an arbitrage profit by exploiting these numbers. So the first thing we want to ask ourselves is there an arbitrage opportunity here? And how do you know if there is, there isn't? Well, the best way to do that is to say, well, listen, why don't we combine these exchange rates and see what the implied cross exchange rate is? So here what we can do is take $2 per pound and multiply it by 110 yen per dollar. You'll notice that the dollars cross out. And that leaves me with what I need, which is yen per pound. So according to what I'm seeing here, it should take 220 yen to buy a single British pound. And yet the quote here is off, isn't it? The quote that we were given offered to give us 240 yen per pound, whereas it should only give us 220 yen per pound. So something's clearly out of whack, which means that we can, in fact, earn profits from this. Now, what I'm going to do is show you this organization of the circles that I used in my solutions so that you can follow the exact same procedure. So in other words, what I would like you to do is set up on a piece of paper the dollar down here, the yen up here, and the pound down here. That's what we've been doing anyway. Well, actually, no. The other time we had the pound up here. It doesn't matter. We can put the circles any way we like. The key detail is knowing whether to go clockwise or counterclockwise. So we're starting in the United States with $1 million. And what I want you to do is show how we could go around this triangle and generate a profit by trading with these exchange rates. Okay, so let me split the screen so you can see what we're doing. And so you know there's really only two options. You can either go clockwise or counterclockwise. So why don't we do this? See what you can do. Try to go around the triangle and make money. And when we're done, you should be able to tell me not only how you made money, but how much you made. So we'll keep the circles in this sequence. We've got those exchange rates on the top. Given $1 million to start with in the United States, here's the challenge. Go through the triangle, in other words, visit all the circles and make trades at each circle and make sure that when you're done, you have more dollars than you started out with. All right, so why don't you take out a piece of paper and we'll take a few minutes and we'll see how this works. Here's a helpful hint though. There's only two things that can happen, clockwise and counterclockwise. If one direction fails to work, then you just reverse it and go the other way. So now if you're a trader, you don't have time to do that. But on a test or on a practice problem like this, just remember if you make a mistake and you go the wrong way, it's easy to correct yourself. You're just going the opposite direction. Okay, so let's take a few minutes and see what you can come up with. All right. So now one thing you might pay attention to here is this. We saw that the quote is 240 yen per pound, but it should only take 220 yen to buy a pound. So that means each pound can be sold for too many yen. So that should be a hint that it's somewhere along the way when you go around the triangle, what you need to do is make sure that somewhere along the way, trade pounds for yen. No matter what else you do in the circle or just triangle, make sure that you're trading pounds for yen somewhere along the way. And that means right here. So this is the leg you want to be traveling up. Now, that being the case, you must therefore get to the pounds with your dollars. You can only obtain pounds with your dollars by trading them along this path, where you get $2, or you have to pay $2 per pound. So therefore, when you get to the pound, you're going to have 500,000 of them. And by the way, just be aware that in some of these cases you have to multiply, and in some cases you have to divide. So how can you tell? Well, you have to line up the units. If I multiply these together, look what happens. The units don't cancel out. I've got to have just pounds when I'm done here. So why don't I try this instead? Whoops, $2 per pound in the denominator will do the trick, because look what happens. This is the equivalent of multiplying 1,000,000 by 1 pound over $2. Algebraically, these are equal to each other. And so now the units cancel out nicely, and we are in fact left with 500,000 pounds. That's what we need. Now, when we go back into Japan with buying yen, remember the bad quote we were given was 240 per pound. This is where the money is coming from, because now we can trade all these pounds, 500,000 of them, for 240 yen each. So you can see here we're multiplying because the yen, the pounds are canceling each other out. And when you multiply those together, this works out to be 120 million yen. All right, so in Japan, we have 120 million yen. And now the last step is to bring these back home to the United States and convert them into dollars. Now here, what we're going to do is divide. Okay, so we'll have 120 million yen.
Wait, I'm sorry, really quickly. Why are you multiplying pound to yen again?
Oh, because if you look at 500,000 pounds times 240 yen per pound, the pounds cancel each other out. That's what we need to do. You have to cancel out the units that you don't want, so that what remains is the one you do want. So,
Okay, thank you.
right, exactly. So you have 120 million yen. Now here, though, we're going to divide, because if you multiply, you'll get the wrong unit. So in other words, 120 million yen divided by 110 yen per dollar is algebraically equivalent to 120 million yen times $1 per 110 yen. Okay, so now you can see that the yen do in fact cancel each other out. And our final result here, which is all we care about, the dollars, we're going to wind up with $1,090,909. approximately. So that tells me that we did our job, because we started with only $1 million, and all of a sudden here we are with more than that, 1,090,909. So we made a profit, a risk-free profit, just three little transactions equals 90,000. Clearly, it's $90,909. How did we make that money? Well, all we did was take advantage of the mispricing here when we were offered 240 yen per pound instead of the appropriate amount, which would have been 220. But somebody out there gave us the wrong quote, and we're happy because we just took advantage of it to make a risk-free arbitrage profit of $90,909. Now, if you made a mistake and you went the opposite direction, in other words, if you went clockwise, you would have ended up with less dollars than you started out with, which means you just went the wrong direction. Okay, so again, there's only two things you can do. You can go clockwise or counterclockwise. One of them will make you money, one of them will lose you money. If, on the other hand, they gave us the correct quote in the first place, like if this had actually been y equals 220, or y 220 per pound, then when you got to the end, you would have discovered that you still had exactly $1 million. And that's how you would have known that this is in fact the correct value. So the fact that we made money means that this is not the correct quote. And it's called an arbitrage because we're taking advantage of a relatively mispriced exchange rate. It's mispriced compared to the other two, the $2 per pound and the 110 yen per dollar. It's inconsistent with the other two. Therefore, we can make money as long as we know which way to go. All right, and of course the name triangular is pretty self-explanatory. It's coming from the fact that we're following a triangle to make this profit. All right, and again, this is the kind of thing, if there's ever going to be a discrepancy like this, it would only last for fractions of a second. Really, only computers could take advantage of it at this point in time. But the fact that this could happen is what essentially ensures that all the foreign exchange dealers around the world will make sure that they're giving you the correct quote, because if not, they could lose a lot of money. So the possibility of this happening is pretty low, but it's not still out of the question, because computers are so fast. If there's even a fraction of a second when the number's off, they can jump in and make money. And that's, of course, true of all arbitrages. Now, what about the second type of arbitrage that we were looking at, covered interest arbitrage? Now, this one is a lot more challenging because there are 4 parts to it. This is all about the relationship between the spot and the forward exchange rate. So there has to be a specific relationship between the spot and the forward exchange rate, which is observed. Otherwise, there will be an issue. Specifically, there's an opportunity to make an arbitrage profit. So now let me remind you what the formula is for determining what is the appropriate forward exchange rate. All right, I know the purple looks weird. Let's just leave it. 1 plus R over times N over 360. And here we have 1 plus R star N over 360. Now, because of the way this formula is defined, we're going to stick with dollars per foreign currency for E. So here, I've changed it to Swiss francs, just for the fun of it. We keep doing pounds all the time. I thought it was time to try something else. So this is the spot exchange rate here. This is E. At the moment, it takes less than $1 to buy a Swiss franc. Now, the forward exchange rate, the 3-month forward exchange rate, which could also be thought of as the 90-day forward exchange rate, also dollars per Swiss franc, is right here. Now, the question is, are they properly related to each other? How do we know? By filling the numbers into this formula, which remember is called interest rate parity, we can find out right away if this forward exchange rate is consistent with interest rate parity. And if not, that means we can make a profit, a risk-free arbitrage profit. Now, if you look at the formula again, R is the domestic rate, which means euro dollars, and R star is the foreign rate, which in this case would mean the euro Swiss franc rate. Okay. Actually, I guess I could put them over here. And finally, N comes from here. For 3 months, remember, we're using a 360-day year. So we can think of 3 months as simply 90 days during a 360-day year. So N in this case is 90, which means it will be 90 days before the exchange rate, or in this case, the Swiss franc, would be delivered if we entered into a forward contract. So what we're going to do now is throw in all these numbers, and let's see what we have. So E is 0.7806. Here we have 1 plus. The domestic rate is 4.8% per year, but we then adjust it for the fact that this is only a 360-day investment. In the denominator, we have the Swiss franc rate. And so what we want to do now is substitute and figure out what we've got. Now, you can simplify this very nicely because each of these ratios is nothing but 1/4. Okay, 90 over 360. So therefore, you have 1 plus a quarter of 4.8%, which is 1.2%. And in the denominator, we can do the same thing. Oh, hold on. What happened? I kind of like that purple. Let's keep it going. Oh. Yeah, got away from me. All right, in the denominator, we have the same thing. 1/4 of 3.2% is actually 0.8%. So you've got 0.7806 times, in parentheses, 1.012 divided by 1.008. Okay, so let's do this. Let's multiply this spot exchange rate, the ratio of 1.02 to 1.008 is approximately 1.00. All right, we don't have to get too carried away with all the decimals, but 0039, let's say 68. That's probably good enough. Then we multiply by 0.7806, and we're going to come back with approximately 0.7837. By the way, the convention in these markets is to go out 4 places, unless it's a small number like the yen, the number of yen, dollars per yen or something like that. If you look at the Wall Street Journal quotes, that's a fairly standard number of digits, 4. So let's leave it at 7837. Now, how does that compare to the number we were actually given? Oh, bad news. They gave us a quote of 7834. So this is the implied. we call it implied forward exchange rate. But the actual quote is here. Okay, so that's off. It's off. It's not much, but it's off enough that we can see that there will be an arbitrage opportunity. So since F is different from the value implied by the interest rate parity condition, this means that there will be an arbitrage opportunity. The question is how to take advantage of it. All right, so here's what we're going to do. We're going to set up a table or a diagram, I guess, where we're going to have the following information. Let's assume that we want to have $1 million involved here. It's just so much nicer with $1 million. So let's set this thing up, this box diagram, it's sometimes called. We'll have $1 million up here. Now, what else do we need to know? Well, let's think about this for a second. What is the problem with this quote? Each forward Swiss franc costs too few dollars to buy. So what does that mean? In other words, we're being offered a price that's too low for the forward Swiss francs. So that means we want to enter into a forward contract to sell Swiss francs in exchange for dollars to exploit this opportunity. So when we go around this graph, now remember how this is set up. We've got dollars here, we've got Swiss francs down in the bottom. The left-hand side of this diagram represents the spot market. This is what's going on now. So if you look at the spot exchange rate, right here, 7806, since that's the case, that means whether we buy or sell dollars or Swiss francs, the amount of francs will be $1 million divided by this number. Okay, and so on the bottom we'll have Swiss francs. So I'm going to take $1 million and divide by 0.7806, and that will give me, all right, hold on one second. 1,281,000 065, or let's round it off, 066. Okay, so whether I start with dollars or Swiss francs, I would like to keep this as simple as possible and make sure that somewhere along the way, the dollar amount is $1 million. Now, that means that in the dollar market, the euro dollar market, either we are borrowing or lending at 4.8% per year in this euro dollar market. And remember too, this is only for 90 days. So how much money will we either receive or pay in 90 days? Well, what we're going to do is 1 million times 4.8% times 90 over 360. Actually, this is not 0.048, it's 1.048, because we need to keep track of the principal as well. So let me write this a little more cleanly. It's 1 plus 0.048 times 90 over 360. That's better. Why? Because this is the amount of interest that's actually being paid. 1/4 of 4.8% is actually 1.2%. So whether we're borrowing or lending, in 90 days, the dollar amount will grow to $1,012,000. Now, here's the interesting part. The forward exchange rate, the bad one that we're given, is 78.34. So if you convert, and this would be, of course, per Swiss franc, if you convert $1,012,000 into Swiss francs using that exchange rate, you're actually dividing, and you'll end up with $1,291,805, let's say. So you notice I'm trying to be careful with the arrows, because I don't want to give it away what you're supposed to do. But all right, I'll give it away. You're supposed to start with the Swiss francs. So let's see why. We start down here and we go up and we trade them for dollars. Now, all right, when we get to the end, I'll show you why we're doing this. Once we have our $1 million, we deposit them in a euro dollar account, which brings us $1,012,000 in 90 days. Now, what we have to assume here, because of the way this is set up, we're going to assume that we borrowed these Swiss francs. Okay, so we started out in the beginning by borrowing 1,281,066 Swiss francs, convert to dollars in the spot market at E equals, okay, the spot exchange rate is 78.06 per Swiss franc, which is exactly $1 million, just the way we like it. We like numbers to be nice and neat, don't we? Yes, we do. So anyway, deposit these dollars in a euro dollar account for 90 days at the rate of whatever they gave us. It's 4.8. Okay. In 90 days, these dollars will be worth $1 million times 1 plus 48 times 90 over 360, which, as we've already seen, is $1,012,000. Okay, so we're starting in the bottom left-hand corner, and we're working our way across. Now, we're going to have, because at some point we have to repay the borrowed Swiss francs, we have to get our hands on Swiss francs. So we will simultaneously enter into a forward contract to buy rather Swiss francs for dollars at F equals 0.7834 for a total of, okay, or in order, okay. Which means that we are buying, let's write it this way, $1,012,000 divided by rather 0.7834 per Swiss francs equals 1,291,805 Swiss francs. Okay, now, did we make money or not? Well, that depends on how much we pay back on our loan. Because remember, there's that little detail where we repay the Swiss franc loan. This will cost us. So here's where we have to figure out the Euro Swiss franc rate. It's 3.2%. And how much will come out of our pocket? Actually, let me fix this diagram a little bit. Just because I'm running out of space. Not that there's anything wrong. It's just out of space. This is the amount of money that we collect from our contract. Okay, so that's coming into our pockets. The amount we're about to show here is how much we need to repay. So what we're going to do is, in order to calculate how much we have to pay back, let's do it right here. The amount that we have to pay back, which will determine if we make money or not, is equal to 1,281,066 times 1 plus this Euro Swiss franc rate, times 90 over 360, or 1,281,066 Swiss francs times 1.008. And if you take out your calculator, you should get 1,281,066 times 1.008. All right, so let's keep our fingers crossed that this is less than the 1.21 up here, 1,291,805 that we collected from our contract. Well, good news. It's 1,291,314. Let's make it 315. So this is the amount that we repay on our Swiss franc loan. 1,291,315. So our arbitrage profit, oh, and let me add that to the bottom here. Okay, so the arbitrage profit is the difference between the two. The amount we collected, 1,281, 291,805, minus the amount we repaid on the loan. Oh, sorry, this is Swiss francs. Minus the amount that we repaid on the loan, which is clearly less, 1,291,315. And so that leaves us with $490 Swiss francs. Well, now you might say, well, that's not a lot of money. It's not. But we could have just as easily started out with $10 million or $100 million or any amount you can imagine. As long as we can get our hands on that money, we can make a nice profit here. The fact that it's a small amount for $1 million is not really relevant. If you look at these gigantic hedge funds, they might be able to raise $1 billion to do this, and then we'll multiply the profit by 1,000. In fact, they might even do more than that. This is how they really make their money. They not only engage in these transactions, but they borrow most of it so that the rate of return is actually quite high if they do it correctly. All right, so now how do we know to do it this way? Well, I did mention up here that because the quote is too low. Now remember what this represents. This is how much we pay in dollars to acquire a forward Swiss franc. The price is too low. It takes too few dollars to buy. Therefore, we want to sell, buy Swiss franc with dollars in order to make money because they're too cheap. All right, so we want to buy Swiss franc in exchange for dollars as they are too cheap. And that's exactly what we did. We used our dollars right here to buy Swiss francs through a forward contract, and as a result, we ended up making money. Now, this is just like the triangular arbitrage in the sense that if you start in the wrong corner of the diagram, you'll end up losing money. So you always start either up here in the US and work your way around and end up back in the US with dollars, or else you start down here. Either way, you'll make a profit if you do it correctly. The thing that you might, one of them, in one case, your dollars are the profit, profit is in dollars. In the second case, you would make your profits with Swiss francs. Either way, it's still a risk-free profit. It doesn't really matter which currency your profits come in, you're still making money. So that's how this one worked. Now, if we had, and you could show, if the implied forward exchange rate was the actual exchange rate, in other words, we replace this with 7834, these two numbers, except for possibly rounding differences, would have been the same number, and we would have made no money. Okay, so there's if F is at its correct level, the amount we collect would be exactly the right amount to repay the loan, and then we would simply break even. So that's how that works. So these are both very challenging, but at least you'll be able to do these at home when this test arrives. So, all right, I'll tell you what. So for that problem set, I'll fix it up and we'll do it again on Monday. Tuesday rather. No, Monday. Sorry. What am I saying? Monday. And in the meantime, what we'll be doing next is chapter 12, which is where we're taking a closer look at where spot exchange rates actually come from. In other words, up to this point, we've been taking them for granted. Here's a spot exchange rate, but we want to dive more deeply into an explanation as to what it is that actually affects the values of spot exchange rates in the marketplace. What factors are causing the dollar, let's say, to be strong or weak, as the case may be? What is it that's driving the values of these currencies? Here, we're basically looking at big picture stuff, the relationships between different exchange rates and exchange rates, spot and forward exchange rates. But now we want to take a look at the actual cause and effect. What is it that's responsible for the values of exchange rates that we see in the marketplace? So that's chapter 12. I haven't posted it yet, but I will over the weekend, along with the updated version of the chapter 2 problem set. I'm going to try to fix it so we can do it again on Monday and get that straightened out. And then we can carry on with 12. And fairly soon, we'll have to start doing a little review so that we can actually have a midterm. The midterm, I think I may have mentioned it, would be based entirely on chapters 2 through 5, which is our discussion of trade. And then we switched over to finance, starting basically in chapter 10. All right. So for now, since the weekend is coming up, why don't we stop right here and relax a little, and I'll see you all on Monday.
Have a
Thank
great
you.
weekend. Okay.
Welcome.
Thank you. Have a good day.
You're welcome. Bye. See you later. No, nobody missed the midterm. We haven't had it yet. No. Don't worry about it. It's not
Bye,
coming up.
Professor.
See you later.
Yeah, sorry. I got my COVID test shot and I had a or my COVID second vaccine and I got a really bad reaction and it lasted
Really?
way longer than I said.
Uh-oh.
So I thought I might have missed it.
No. So I haven't had mine yet. What kind of reaction did you have?
Oh, just flu-like symptoms, but it was apparently I had an unusually strong immune reaction. Apparently it's inversely proportional to your age. The younger you are, the more likely you are to experience very strong flu-like symptoms.
Wow. This is one of those rare occasions when it does not pay to be young.
Apparently so.
I wasn't aware of that. Well, I'm glad to hear that. I was kind of nervous about it, but I've discussed this with my doctor, and well, let's just say I'm going to get it. But
I mean, it's sure as hell better than COVID, but it's just it was like having a nasty flu. Nothing
How
catastrophic.
long did that last?
For me, about 4 days. So
Wow, that's pretty bad. I thought you were going to say like 1 day. 4 days of
Apparently-
flu.
so apparently I had a really unusually strong reaction.
Okay,
Like,
so
they-
you're
they- Yeah, I was just unlucky. I was outside the zone, but yeah, that was where I was. And anyway, take care.
all right. So see you next time.